In the last section, we looked at the square root of -9, and we came to the conclusion that it is not real because if I'm trying to break down -9 into two matching factors, if I do -3 times itself, I get +9. If I do +3 times itself, I get +9. So I don't have a number times itself that will give me an answer, a negative answer. I do not have a number times itself that will generate a negative answer. So we're going to use what we do know to enforce what we don't know. So I'm going to rewrite 9, or -9, as 9 times -1. And then remember that each factor can get his own radical. So 9 can get his own radical, -1 can get his own radical. And the reason I'm doing that is because I happen to know that the square root of 9 is 3. Okay, so this is a 3, and then this is what's causing the issue, is this -1 right here. This square root of -1 is causing an issue. And so anytime I've got that square root of -1, I am going to write that as I, and it stands for the imaginary number. I is not a variable. It is a symbol, which means its value is always the square root of -1. Okay, so it's not going to be the square root of -2 at some point, anything like that. If you see I, it indicates that you're actually saying the square root of -1. Okay, so it's a symbol. And what this allows me to do is it allows me to simplify these radicals, but now I can deal with the ones that have negatives. So I'm going to take it from just saying, hey, that's not real, I can't do it, it doesn't work, to now I can turn around and say, oh, let's break it down as far as we can, and that square root of -1, I'm going to write as an I. So the way I read that is either 3i or 3 times the imaginary number. Since we are lazy math people, we are going to say 3 times the imaginary number. Okay? So knowing all of that, what we would like to do is do some examples and just talk them through kind of slowly, because a while ago it was not okay to have a negative under the radical, and now suddenly it is. So I've got the square root of -16. Immediately my brain kind of goes, whoop, there's something going on here because I've got a negative under an even root. Remember, negatives under odd roots are okay, but negative under even roots are not. And we're going to keep this straightforward. I'm not going to surprise you with anything in this section, but all of these are going to be square roots in this section, okay? So I've got the square root of -16. Well, immediately that negative pops its ugly face up, so I'm going to rewrite that as the square root of 16 times -1, and then each factor is going to get his own radical. So now I know what the square root of 16 is. The square root of 16 is 4, and the way I'm going to handle the square root of -1 is by writing I. So that is 4 times I, okay, which is the imaginary number. So now I've got the square root of -10. So immediately I see that negative under the radical. That tells me I better do something about it. So I'm going to rewrite that as 10 times -1 under the radical. So that gives me the square root of 10 times the square root of -1. Well, now 10 breaks down to 2 and 5. But again, this is not useful. This doesn't help me at all because I'm looking for matching factors. I need pairs of factors. 2 doesn't have a friend, 5 doesn't have a friend. So I am stuck. I cannot simplify the square root of 10 any further. And so I can simplify the square root of -1. So here's what I'm going to do is I'm going to write it a little bit backwards. I'm going to write I times the square root of 10. So I'm going to put the I first in this case. And that is simply because if I write the square root of 10 times I, does that I belong inside the radical with a 10? Or does it belong outside the radical next to the square root of 10? And so for us to be very, very, very clear, I'm going to write the I out front so that you don't think, well, it could be in, it could be out, I'm not sure. So now we're just going to write it out front. So that way it's I times the square root of 10. All right, I've got the square root of negative 24. So the first thing that I see, that negative, I got to take care of the negative. So I'm going to rewrite that as 24 times negative 1. And now let's break down 24. Okay, so I'm going to break down 24 as 4 times 6. I like 4. I could have chosen 8 and 3, but neither one of those were perfect squares. I could have chosen 12 and 2, but neither one of those were perfect squares. So I'm going to start making decisions that will help me get to my end result faster. Okay, so, and I'm okay with 6 because his factors are 2 and 3, which means he's not going to break down any further. So what I have now is the square root of 4 times the square root of 6 times the square root of negative 1. So 24 is 4 times 6, and then the square root of negative 1 gets his own radical too. Why did I do that? Because I know what the square root of 4 is. The square root of 4 is 2. I'm going to go ahead and rewrite my I right here so that I don't think it's under the radical, because the square root of 6 I cannot simplify any further. So I have 2 times I times the square root of 6. All right, I have negative times the square root of negative 180. Again, I see a negative inside my radical. Don't let this one throw you off. He's just going to come along for the ride. Okay? He is going to come along for the ride. So the next thing I see is he's coming along for the ride, and now I've got 180 times negative 1. Well, I know that 4 will go into 180. So let's try and start breaking this down. 180 divided by, 180 divided by 4 gives me 45. Okay, so I'm going to do 180 divided by 4 gives me 45. Now in the back of my head, I know that 45 can break down as well. So 45 is going to break down to 9 times 5. Okay, so what do I have here? 4 times 9 is 36. So that's going to better this. So I'm going to rewrite him as 36 times 5. Why did I multiply it back again? I could have taken the square root of 4 and gotten a 2. I could have taken the square root of 9 and gotten a 3. And then the square root of 5 would have stayed inside the radical. But this, I can just rewrite it as a large perfect square times 5. Okay, so this is going to be negative 36 under the radical, 5 under the radical, and negative 1 under the radical. And that just makes life a little bit easier. So do I know what the square root of 36 is? I do. It is 6. So remember, this negative out here is just coming along for the ride. What about the square root of negative 1? He is I. And why did I dive over to him? Because the square root of 5 is going to stay inside the radical. So I end up with that answer. Okay? Now, what would have happened if I had come to here? Then this 4 would have gotten a radical and become a 2. This 9 would have gotten a radical and become a 3. Well, what is 2 times 3? It's 6. So you would have gotten the same answer. All right, now we've got to be very, very, very careful about order of operations. So I've got negative 2 plus the square root of negative 8. All of that is over 2. So this plus sign, we did this in a previous section, where this is just, this 2, this denominator belongs to both parts of the numerator. So it's like I got a common denominator, and I wrote it over the same denominator. So this is going to go here, and this is going to go here. So I'm going to just do this a step at a time. If I look at order of operations, let's look at the numerator first. There's nothing to be done out here, but I can rewrite this negative 8. Okay? So this negative 8, I can rewrite 8 as 4 times 2. So this is going to be times negative 1. I'm going to get a square root of 4 times a square root of 2 times a square root of negative 1. So that becomes square root of 2 plus square root of 4, square root of 2, square root of negative 1, all over 2. Well, I know what the square root of 4 is. It's 2. Okay? So I've got this other stuff that's coming along for the ride now. So negative 2 plus, this becomes a 2. The square root of 2 is stuck. And the square root of negative 1 is I. And all of that is over 2. All of that is over 2. All right, so this is going to be rewritten as negative 2 over 2 plus 2I root 2 over 2. I cannot reduce this 2 and this 2. The square root of 2 is inside of a radical, or 2 is inside the radical, and he can't talk to people outside the radical. Okay, so this is going to reduce to negative 1 plus, and then this portion right here I'll be able to reduce. So 2 divided by 2 is 1, and that'll leave me with I root 2. Okay? All right, let's try another one. I have 6 minus the square root of negative 162 over 3. So the first thing I notice is I got a negative under an even root. So negative 162, I can break that down to 2 and 81 and negative 1. Okay, so I saw it was even. If I put a 2 in there, it comes out to be an 81. So I'm going to rewrite just this part. So I've got a 6 minus a square root of 2, a square root of 81, a square root of negative 1, all over 3. Okay, so now let's simplify. I've got 6 minus. I'm going to, because this is just this times this times this, order doesn't matter. Okay, so I'm going to go ahead and do the stuff I know first. So the square root of 81 is 9. The square root of negative 1 is I. And then the square root of 2 is going to stay inside. Okay, so I did the square root of 2. The square root of 81 is 9. The square root of negative 1 is I. And now I can rewrite that as a 6 over a 3 minus a 9I root 2 over 3. So 6 over 3 reduces to 2. 9 over 3 reduces to 3I root 2. And that is the answer to that one. So now I've got a negative 8 plus the square root of negative 12 over 40. So the question is, what am I going to do? Because if you'll notice, that's going to be a little bit different. Before it was all nice and pretty, but 40 is a pretty big number. Okay, so these all reduced out all nice and pretty. This one's not going to. But it's okay. We know how to do this. What's the first thing that's screaming in your face? I've got a negative under that radical. So I'm going to break down negative 12 into 4 times 3 times negative 1. And again, I like 4 because he's a perfect square. So I've got a negative 8 plus the square root of 4 times the square root of 3 times the square root of negative 1 over 40. So now let's see what we know. I know the square root of 4 is 2. I know the square root of negative 1 is I. And I know the square root of 3 has to stay inside. And that's over 40. So now that 40 is going to belong to each term in my numerator. So I've got a negative 8 over 40 plus 2I root 3 over 40. So do those reduce? Yeah, 8 and 40 reduced by 5, or 5. So I get a negative 1/5. 8 divided by itself is 1. 40 divided by 5 is, 40 divided by 8 is 5. Plus, I've got a 2 over a 40, so that's going to reduce to 1 and 20. So I have an I root 3 over 20. And that is your final answer.